In today's video, I'm going to teach you how to use ChatGPT for engineering, a step-by-step guide. We'll walk through a clear workflow that protects your intellectual property, sets the right analytical depth, and turns conversations into structured engineering outputs you can verify and share. First, abstract and de-risk your technical context. Before sharing calculation tasks, design parameters, or part geometries, strip out anything proprietary while preserving the engineering logic. Instead of pasting exact part numbers or project identifiers, describe the physics and constraints. For example, frame it as a role and scenario. Act as a senior mechanical engineer reviewing a structural support bracket under a FOB 5K cyclic load. Avoid pasting raw source code, unreleased CAD metadata, or confidential pricing. Focusing on boundary conditions keeps your core IP safe while giving the model what it needs to help. Next, set your target engineering units and choose the right model tier from the top header of your workspace. Keep it on the instant tier for rapid tasks like unit conversions, comment syntax changes, or drafting supplier RFC templates. Switch to the thinking tier when diagnosing fatigue, analyzing complex thermodynamic cycles, building compliance matrices for standards like ASME, IBC, or ASE 7 to 22, or verifying failure modes. Picking the tier up front routes your request down the right processing path. Now prime with boundary conditions rather than open-ended prompts. Press Shift plus Enter to draft a structured message such as act as a principal systems engineer, material scientist, and design review auditor. I want to build a preliminary structural validation checklist for a component operating at insert operating conditions, for example, 150 degrees C under continuous friction. Before you generate any failure mode lists or recommendations, ask me three highly targeted questions, one by one, regarding my specific material selections, exact load vectors with units, and space envelope constraints. Answer those alignment questions sequentially. Once aligned, open your engineering workspace canvas. Type Canvas, create a structured engineering design review brief based on our boundary conditions. Format this document into an organized table mapping out potential failure mode, severity classification, stress or thermal thresholds, and recommended validation steps. Your chat remains on the left, while a clean technical document opens on the right. Refine directly in the canvas. Highlight a row, tap the floating comment bubble, and type an adjustment like our fatigue lifecycle requirement has shifted. Recalculate this row with yield strength changing from 200 MPa to 350 MPa, set safety factor to 2.5, and update the validation test recommendation. Only that block updates. Finally, verify and export. Use the globe icon to run a grounded web check for current code variations, then confirm sources. When satisfied, click export or download to save your brief as Word, Markdown, or PDF for your change control system. That is all. Thank you for watching, and see you guys on